heat engine efficiency, question number 11. Please do calculate, and remember, there are no units here. This is just a number, 0.5 in this case, yeah? So some of you write J probably for joules. No, energy is canceled out, joules cancel out. So this is dimensionless, efficiency is dimensionless, yeah? Then you find temperature T1 from this equation, in this case measured in kelvins. Please do calculate. And please do calculate the compound capacitance for parallel case and for the case of series. Yeah, obviously it will be 6 farads for parallel case and 0.5 farads for series case. Yeah. So what is the resistance of inductor to direct current? 0 or almost 0. Yeah, here 15, question number 15 estimates estimate the distances between the atoms of element number T in the periodic table of elements. So type your student number here. And then if you don't see your T number in the list, then you must write this line for your T number, right? You must find the element in the periodic table. You must find atomic weight in kilograms in this case. Usually it's given in grams in periodic tables. You must divide it by 1,000, so in kilograms. And then the density in kilograms per cubic meter, and then go to 1, just like that. So for example, if your T number is 1, then you must copy this line and write T1, then find atomic weight for hydrogen, density of hydrogen, etc., etc. If it is 1 for hydrogen, yeah. So please do that. If your element is already here, then just type your student number here, and that's it. No need to calculate. Yeah. So energy and momentum of photon, please type your student number here and give the correct number of significant figures, either 7 or 8 or whatever it is, and no need to calculate. Similarly, energy and momentum of photon, if it is given by its wavelength. So type your student number here and give the correct number of significant figures, and no need to calculate here. Just write correct number of significant figures. Now the waves of matter, once again, you type your student number instead of this, and 1 or 2 significant figures, or whatever is the number of significant figures for your case, and no need to calculate, yeah? Same thing for this kg desk or whatever. Type your student number here and give the correct number of significant figures, no need to calculate. And similarly for Bohr's model, type your student number here and give the correct number of significant figures for angular momentum, and no need to calculate in this case, yeah? So for this case, type your student number here, and please do calculate, because it calculates the difference in energies. In other words, for hydrogen, the electron changes its location in the atom, and we need to calculate the energy difference because only 1 significant figure. So your student number here instead of this, and calculate and give the energy difference, yeah, in electron volts in this case, yeah. So please write the ground state configuration for your element number T periodic table. For example, for hydrogen, it will be 1s1. So in that case, T is equal to 1. But if T is equal to 2, 3, 4, etc., then you find the configuration of ground state configuration for your element. Yeah. And then perform correlation and regression analysis for elements and for elementary particles. You see that here the atomic weight and density correlate pretty strongly, and there is a relationship if you use the approximation, using the least squares approximation, right? And for particles, there is a strong correlation, negative correlation. So the longer is the lifetime, the smaller is the mass of the particle. Just like people, usually if they're very massive, they live less than people with smaller mass usually. Yeah. So what particles mediate electromagnetic interactions? Photons, D, yeah. Photons, they are bosons which mediate electromagnetic interaction. 25. What particles mediate strong interaction? Well, gluons. These are the bosons of strong interactions. Strong interaction. B, gluons. And I think most of you answered this correctly. Give the structure of neutron, down, up quark. Give the structure of proton, up, down quark. Yeah. Now find annihilation energy of k grams matter. Please type your student number here instead of this, and give the correct number of significant figures, and no need to calculate, okay? Question 29, the remaining mass will not be zero, so please make sure you do calculate, don't copy zero, zero is wrong. So please type your student number here and give the correct number of significant figures, and it is better not to calculate, because if you calculate, often it gives you the remaining mass as zero, which is not true, so you need to adjust it so that it's not zero. As you hopefully understand from calculus, this exponent will never be zero, it will only be zero at the infinity, and our numbers k and t, obviously they are not infinite, right? So question number 30. How many times electromagnetic force is weaker than strong nuclear force? 137 times approximately. So A is the correct answer. And finally, question 31, explain main concepts, laws, theories of the physics, excuse me. So what that means is, please write anything about what you understand about anything like general, like for example, theory of everything, quantum computing, quantum teleportation, general relativity, anything which might be interesting for you, or maybe that you need or you want to share, so that I try to understand what you understand, and maybe I can help you to understand things better. Yeah. So I hope you submit task 2 as soon as possible, hopefully tomorrow. If you haven't submitted yet, some of you have submitted, but I haven't checked everything. Maybe more of you have submitted, but if you haven't submitted yet, please do submit. It's really important before the midterm exam, so that I know what you understand, what you don't understand, so that I can help you. I can try to help you, yeah? So please do submit task number 2. So any questions, any comments, please? Okay, so I hope you know how to use macros in Microsoft Office. Yeah, maybe I can show you very quickly. So, so this question number 7, I will copy and paste the code from here to the macro. Let me stop sharing and let me share the macro, my macro, yeah. So I hope you can see that, yeah. So I copy the code from for example, into the macro, and I run the code. But before running, of course, I must see what is the number of significant figures, 1, right? So I go to, how can I do this? Okay, I click run. Yeah, run. So 600 newtons in my case, yeah, one significant figure. 600, so that's one significant figure. 6 times 10 to the power of 2, 600. And this is my student number. You need to write your student number here, right? So the next, for fluid, right? For fluid, my A is, I think 6. So in my case, it's one significant figure, right? So in my case, it will be one significant figure. So for the next question, so the resistance force, one significant figure in my case, yeah. And then I just go run, and I run if necessary. So 7,776, that's 800 to one significant, oh, sorry, 8,000 to one significant figure, 8,000, yeah. 8,000 newtons, and one significant figure, yeah, one significant figure, 800 newtons in my case, yeah. So the next is the efficiency of the heat engine. I must copy paste, and it is one significant figure, obviously. So no student number here. So I run one significant figure 0.5. So 5 times 10 to the power of minus 1, it's dimensionless. So no units, one significant figure, correct. Then the next one is temperature calculation. I think the temperature should be 600 kelvins, also one significant figure. Yeah. So the temperature, 600 kelvins, one significant figure. Yes, correct. Next, capacitance. Compound capacitance will be 6 and 0.5, one significant figure every time, yeah? So pasting this into the code window gives us this, and I run 2b6, so that's correct, one significant figures, and 0.5, because only one significant figure is allowed, yeah? And for infrareds, of course, and one significant figure, yeah? So what is the resistance of inductor to direct current? Almost zero. Estimate the distance between the particles. So I don't have time to do it for 56. Is it 56 in here? Is 56 in here? No. No, okay. So one significant figure. So I'll just make it, let's say 0.9. Doesn't matter. Sorry, not 0.9, but 0.9 at the end, right? Or whatever. For example, what I say 12, right? So I will make it 12. So I run, and what is the distance? So about 3 times 10 to the power of minus 10 meters. Yeah, so that makes a lot of sense. In meters, of course, one significant figure. Yeah, so it will be 3 times 10 to the power of minus 20. So 3 angstroms, yeah, for number 12, which is magnesium, yeah. Okay, so next, energy and momentum of photon. So I don't ask you to calculate in this case, but maybe I can quickly copy paste and quickly calculate. And but before calculating, of course, I must give the correct number of significant figures. In my case, 8 significant figures, because my student number has 8 significant figures. So I run, so I get roughly 1 times 10 to the power of minus 26 joules, and then roughly 4 times 10 to the power of minus 35 kilograms times meters per second for momentum, and 8 significant figures. Next, similarly for the wavelength given. So maximum 4 significant figures, and in my case, it is exactly 4 significant figures. I mean, there will be 4 significant figures. So exactly 4 significant figures, yeah. And I don't need to calculate, but let me calculate. So that's the energy, about 1 times 10 to the power of minus 18, 10 to the power of minus 18 in joules. And this is momentum, about 4 times 10 to the power of minus 27 kilograms times meters per second, and 4 significant figures, yeah. So waves of matter for electron, I don't need to calculate, but I adjust significant figures, and then maybe I will calculate. So in my case, it will be 2 significant figures, yeah. 2 significant figures, and then I run. So that's about 2 times 10 to the power of minus 10 meters, the wavelength, and then 2 significant figures. That's it, yeah. Next. wavelength of k grams desk. So once again, I give the correct number of significant figures. Excuse me. Calculate. Давай позвони мне, пожалуйста, позже. Я сейчас не могу разговаривать. Давай я тебе перезвоню, наверное, через пару часов примерно. Позвони через пару часов примерно, пока. Sorry. Yeah. Sorry for that. Yeah. So, so we calculate. So about 2 times 10 to the power of minus 10 meters, and two significant figures for the waves in this case. Yeah. So that was the wavelength of k grams matter moving t centimeters per second. Now Bohr's model calculations. So once again, I don't need to calculate, but firstly, I say that 8 significant figures because my student number has 8 significant figures, and I can run it. So the energy is negative, that's correct. So about negative 3 times 10 to the power of minus 10 in electron volts, and then 3 significant figures for energy, and then for momentum, about 2 times 10 to the power of minus 27, and angular momentum is measured in kilograms times meters per second, meters squared, sorry, divided by second, and 8 significant figures for angular momentum, yeah? So that was Bohr's model. And again, the Bohr's model for change of location of electron and the energy change during this process. So one significant figure, so I need to calculate. So let me paste it to the macro, and I run. So it's roughly minus 4 times 10 to the power of minus 3. Yeah, electron volts, that's the energy change. And one significant figure, yeah? Any questions, any comments? Okay. So the ground state, then we have done this. Okay, annihilation energy of k grams of matter. So I don't need to calculate, but I will try to do that. So that's annihilation energy code. So obviously in my case, exactly 4 significant figures, my k number. So I run and it gives me roughly 3 times 10 to the power of 17 joules and 4 significant figures, yeah? Okay, so is there anything else? Okay, remaining mass, okay. Just like I said, remaining mass may be 0, but that's incorrect. So if it shows 0, then we must adjust. So that's why it's better not to calculate, because the remaining mass may end up being 0. And how many significant figures do I have? Okay, so why 1 or 2? Just a moment. Okay. My T number has 2 significant figures, so therefore 2 significant figures, yeah? Now, if I run, it will give me 0, yeah, 0. That's incorrect, yeah, I need to adjust for that. So remaining mass is not 0 kilograms, it's more than 0, yeah? And this is the half-life, about 1 times 10 to the power of negative 2 seconds, yeah? And 2 significant figures. So, yeah, so make sure that if you do calculate, your remaining mass is not 0. You adjust your numbers and then say that it's this number times this or divided by this or whatever it is. So yeah. The remaining mass is not zero. So, okay. So, any questions, any comments, please? Mm. Okay. So, if you don't have questions and if you don't have comments, let me see who is present. Let me see who is present so that I don't forget. Huh? Bayu Arif Setiawan, Muhammad Diyar Ramahan, Nabhan Muhammad Raihan, Nurul Nabila Khairul Ilham, Muhammad Andhika Putra Pratama, Ibnu Salam, Adam Apriyasya, Ranga Raditya Putra Pratama,
Present, sir.
Muhammad Farid Ali Wahyuddin,
Present, sir.
Muhammad Fauzan Bintan Afdisa, Carnelia
Present,
Raisha
sir.
Wulur. Thank you. Okay. Virgi Fabrian Hermawan,
Present, sir.
Melissa Claudia Sapitri, Christian Jonathan Pascual, Siti Rai Hana,
Present, sir.
Maria Aprilianto, Grandi Damar Negara,
Present, sir.
Ali Sirajuddin, Brian Jonathan Utapea, Muhammad Haikal Bagus Putra, Muhammad Naufal, Zabrina Fitria Ramadhani Napitupulu. Okay. I hope I have marked everybody who is present. Okay. So, if you don't have questions and if you don't have comments, I would like us to go back to quantum computer because it's really important. It seems to be super important. Yeah. So I would like us to spend more time studying quantum computer. Yeah? So, which one we haven't watched?
Ini putus satu sebenarnya. Bukan putus sih sebenarnya nih, ininya hilang nih.
So
Lingkaran
this is
ininya
quite
hilang.
new.
Ini sih
Oh,
masih
okay.
bagus. Bagus
Have a
parah.
question?
Teguan doang karena kagak gue mainin.
Okay.
Ini merah.
No worries. It's okay. If you have been present, don't worry. Just check later if you have been marked as absent. Then you let me know. I will try to fix it. Yeah. Okay. So let us try to watch quantum computer video. I'll try to give you the link.
to precision selection. It's the accuracy of each. Current limitations on the speed and precision. Also, logical aspirations.
Questions, comments, please? I would like us to look at quantum entanglement. Let me see. Yeah, quantum entanglement, probably this one.
Quantum physics. Hello? Each coin flipped will have a 50% chance, and that's true no matter what you see when you look at the other. And the time is it's going to take years to. So if Alice had see what quantum entanglement does. Whatever. Sooner than the speed of light. Communication. And you can't. in computing, which we'll discuss later. How do the particles
Well,
we can use? The results of these experiments will forever change.
So what do you think? So it seems that there may be serious problems for quantum computers. Yeah. Maybe they will never exist, even though people are very optimistic about them. Yeah. So yeah, please think about that and try to understand. Maybe instead of quantum computer, it will be like molecular computer. Still very powerful, but not as powerful as a quantum computer, which is basically atomic computer, basically, or even subatomic computer. Yeah. So there may be something. Probably there is something in that, but maybe it will take longer than many people thought. Some people hope that it will happen in few years' time. Some people say in 10 years' time. Some people say in 15 years' time. Some people say that quantum computers will never exist. They may never substitute our classical computers. Yeah. So if you don't have your own opinion, what I would like us to do, I would like us to look at fractals in physics. Yeah, fractals are just graphs of functions, pretty beautiful pictures, as many people think. But it's another important topic for question 31. If you know fractals, if you understand fractals, if you want to know fractals, please write about fractals. So let me see if I can find anything about fractals. I think this is the one, right? Or maybe this one is better.
current is a simple function. Geometry is
Yeah. What do you think? Questions, comments, anything? Questions, comments? Okay. So as you can see, fractals can be almost everywhere, and almost every physical object can be represented as a fractal. Not almost every object, I'm sorry, but many self-similar objects like cauliflower, like tree, bush, clouds, other things, many other things, right? Galaxies, the universe, yeah. And the equation is very simple equation, as you could see. It's just f of z is equal to z squared plus c, where z is a complex number. So for such a complex structure, the equation is so simple, yeah. So let me see. Okay. We'd like you to be aware of pseudoscience. Pseudoscience is very often a big problem, especially um, in poor countries where people don't have access to scientific. And please be very careful, because many people have become victims of pseudoscience. Even my parents, who are quite educated, my father is very smart, very educated, and even he became a victim of pseudoscience. So please be very careful about that, yeah? So especially if people don't understand science very deeply, it's easy to deceive them. That's why probably if you have doubts, check Wikipedia, check the websites, talk to people, make sure that what you are thinking about, what you are discussing is really worth to discuss, yeah? Because if it is pseudoscience, then it's better not to deal with that if possible, and to focus on more important things. Okay. So there is even quantum fractal. Yeah, quantum fractal. Maybe we can look at this one, quantum fractal.
Oh, or it looks like a miniature version of the whole. But the thing about same Okay, and you divide it in half. But allows the electrons to begin very slowly. The resulting shape, both spatial and in function, is
Everything. So I hope you can interact more actively. Okay. So as you can see, fractals are in fractional dimensions. For example, not one dimension, not two dimensions, but for example, approximately 1.5 dimensions. Yeah. So that may be strange. Remember, we discussed how many dimensions are there in the universe. We said maybe 3 or 4 or 10 or 26. But for fractals, the dimensions are fractional. Yeah. On electrons with fractional dimension, quantum fractal. I don't know the answer to this question. I don't know. I need to think about that. I will try to add it in the list of questions. Maybe we can talk about them as quantum fractal, but I need to check that one. I need to, let's see what is quantum fractal exactly. Interesting question. Wow, that's a great question. Quantum fractal. Yeah, that's the only one that we have seen. Quantum chaos. Yeah, they don't really define what is quantum fractal in this video. So I don't know the answer to your question. I will think about that. Interesting question. Sorry, quantum fractal. Yeah, so yeah, at quantum level, so that's quantum fractal. Yeah, probably. So yes, if it is at quantum level, then it's quantum fractal. So Sierpinski's triangle at quantum level may be considered as a quantum fractal. Yeah. Okay, interesting question. Any other questions, please? Okay. Quantum fractal. Not really. Okay. So seems that might be better to look back at quantum computer. Let's look at this one.
Normal mysterious physics logic going on the inside. My computer server. Time scale. The classic way to demonstrate quantum area with two slits. Sunlight goes through the cap. Humans. Security by factoring the product of two prime numbers. Each prime is long, and they serve a unique are fragile. It's hard to completely stop its lasers in super cooled or vacuum chambers. Any noise in the system leads to a state called using another set of algorithms. Quantum computing has advanced slowly. And then with quantum random number sample the likelihood. Sycamore works fairly current starts to behave like a quantum mechanics. Yes, it's fields where different energy demonstrate
Do you think? You ask great questions. I like that. So we need to know quantum gates and Shor's algorithm. I just want the short one. There we go.
Q1 tastes gluten plus
You understand? That's a complex stuff. Yeah. So we have longer videos about quantum gates. I would like us to look at Shor's algorithm. Shor's algorithm. Sorry. It's too long. Mhm. I don't think they are directly related, fractal and quantum gate. Remember, we dealt with binary gates. Yeah, remember we dealt with AND gate, OR gate, NOT gate. So similar gates exist in quantum computing. Yeah, fractal. I don't know if it is directly related. Of course, everything is connected to everything, but I don't know how fractal is related to quantum gate. Yeah, interesting question. Interesting question, but this one is a little bit more confusing than the previous one. Yeah. Well done, great job. So we try to look at Shor's algorithm. So Shor's algorithm basically breaks the encryption. So fractal and quantum gate. Is there any link? I don't see the link. It seems that there is no link. So okay, let's look back at quantum gates once again. I just want the short one. Okay, let's look this.
We discussed. States.
That's it. So as you can see, it's a pretty complex mathematics and physics. Those operators are acting on wave function. So minus, plus, I, minus, I. Yeah. So quantum gate. Hmm. Um, Maybe it's better quantum algorithm. There we go.
Solve. Probably like as a because what's Charles?
You understand? You need to explore this more. So basically, I want to find the short one so that we can um, activity.
Isso assim, e tipo, quanto mecânico may items multi-app operate all the others are I see that the
Yeah. You understand? So this psi is a wave function. So it's a wave function of Dirac's equation, or simplified in a way. Schrodinger's equation is a simplified version, kind of simplified version of Dirac's equation. Yeah. Yeah. I just want the short one. I just want the short.
cell instructions. Square of a number. And once
I understand quantum algorithms. I'm thinking of maybe watching something a little bit longer.
represent
Yeah. Okay, no worries.
Example, which we can illustrate using Qt tools.
Okay, questions, comments? Do you understand? We're discussing quantum algorithms. Yeah. So they are probably more complex than classical computers algorithms. Maybe we can look at this Shor's algorithm, a little bit longer video.
Using the number 314. Quickly happen. Yes, 101. Just stated the remains. Maybe that this would mean we had a frequency. Let's see. Result in this transition of one of our people. We glossed over in the main video. Make more distance the quantum Fourier transform doesn't multiples of one over. Anyway, again, last one. Essentially,
Understand? Okay, I would like us to look at quantum Fourier transform. I hope you know what Fourier transform is, but now let's look at quantum Fourier transform. I just want the short one. So,
Anytime you go to the calendar. Circle.
So it is the square root of -1. I hope you know that. Yeah. Okay, so as you can see, there are quantum algorithms, quantum gates, quantum Fourier transform, and a lot of things to study. And of course, to study the possibility of quantum computer itself. As you can see, there are so many problems on the way of creating massive quantum computers. Yeah, used like we use laptops today. Yeah. Okay, so any questions, any comments at this time? Okay, so today we studied quantum physics, fractals, we would say classical physics. Excuse me. Classical physics. Anything else? I hope not. Okay, quantum algorithms. Quantum. That's enough. Okay. I'm still waiting for your questions or comments or both. Okay. Let me see. Okay. So I'm still waiting. 6:30 p.m. 5 p.m. on Wednesday. Okay. So make sure that I save this. Today is Wednesday, yeah. Okay. So if you have no questions and you have no comments, then maybe it's better for us to finish for today. What do you think? Okay. Thank you so much for your time, patience, and effort. Please have a great evening, and please do submit your task 2 in physics, maybe tomorrow or this week, please, because I need time to give you some kind of feedback. If you haven't submitted yet, please do submit your task 2 in physics as soon as possible. Okay? Thank you. Take care. Bye bye.